Hey everybody, so here we go with our first kind of practice video lesson on this. We'll see how this works. We're just kind of rolling this out kind of slowly, trying to figure out what the heck we're doing. So don't panic if it's a little different than what you're expecting or it's not quite as formal. So this little lesson, we're going to kind of wrap up density is basically what we're going to do. I'll remind you that before all this craziness happened, we were doing a unit on math and numbers and measurement and precision and sig figs and scientific notation, all that kind of good stuff. And this is the last standard that's on this. So this one is about density. And we've seen density before this year. So I figured this would be a really good one to kind of ease in to start off with what we're doing here in this new world that we're in. So density, you guys know what this is, all right? Density is right? Mass over volume. So it is the degree of compactness, basically how heavy something is for its size. So something like a rock is pretty dense, something like foam, not so much dense. Wood, not so much either. And a couple of things to kind of keep in mind about density and when you're doing density calculations, density math, and that kind of stuff. Number one, it's units. So don't forget when you're dealing with densities, the standard unit of density is typically, of mass, is typically grams. The standard unit of volume, it's mass divided by volume. Remember that volume is how big something is, how much space it takes up. And our two typical units are either cubic centimeters, which you can kind of see on the board or on the screen over here as cm3, or we would use milliliters. So we'd use cubic centimeters if we're talking about measuring a box. So like if we're talking about this particular density box up here, we would have some different kinds of, I gotta move this little guy out of the way. We would have, for calculating volume, right? Volume is length times width times height. So if we're going to do something like that, we would have centimeters over here. I don't know why it's doing all this weird centimeters over here. And then we would have, which one am I missing? This one, centimeters over here. So centimeters times centimeters times centimeters is cubic centimeters. That's how that works. If you're trying to do something like milliliters, if you're dealing with irregular solids, something that's a little bit different, you could do like drop a rock into some water and you get the amount of milliliters, or you're just talking about liquids themselves. And then the last part is if you're doing mass divided by volume, then your units of density is either kind of typically recorded in grams per cubic centimeters if it's a box or a cube, or if it's in grams per milliliter. One of the kind of things to realize is that there is a relationship between these, that a cubic centimeter and a milliliter are the same thing. Kind of nice little trick that we can kind of use to help us move on with these. So anyway, density, how compact is a substance? So typically what you're going to end up doing with these kinds of things is going to be either to calculate density or to identify a substance based on its density. Density is a physical property or a physical characteristic, and it's relatively unique for each substance. It doesn't have to be. That's what it says there's some chance overlaps, but a lot of them are relatively different. And densities can be relatively small, like less than 1, or they can be relatively high, like up to like even 19 or 20, depending on the element that's on there. So there's 3 examples on there, like foam is a real low density material. It's really light and spongy. It only weighs 0.3 grams per cubic centimeter. Diamonds are a little bit more dense. They weigh about 3.5 grams per cubic centimeter. And then iron, of these 3, metal, is definitely the most dense of these 3, and it weighs about 7.8 grams per cubic centimeter. So if you have the same size block of each of these 3 substances, they would have different masses. That's basically what density kind of tells you something about. So a couple little quick points for you to go look up, and that's kind of what these things are. I'm actually going to post these as questions off on the side later on, but you can kind of get a head start on it. Do a quick Google search. I want to know what the most dense element and the least dense elements are. So see if you can go find those and post them up. We'll give you some little bonus points to that, just to give some idea of kind of the range of densities. And you can just Google that. Just make sure that you're looking for densities in metric units, so grams per centimeter, cubic centimeter, or grams per milliliter. All right, moving on. Keep in mind that most of the time what we're going to be talking about in here is definitely going to be density of solids, but density does apply to liquids as well. And I just put a couple of quick examples up here to kind of show you. Over here on the left is we've got a typical salad dressing, right? Unmixed, heterogeneous mixture. We've got the oil layer on the top, got the vinegar layer on the bottom. You can tell just by looking at this right now that these 2 layers have different densities to them. The one that's on the top is lower density. The one that's on the bottom is higher density, and it sinks. That's basically how that works. And one of the things that you can do if you have fun around your house is you can actually create a kind of funky, they call it a density column. It's kind of a fun thing to do where you can get a bunch of different liquids around the house. A lot of these liquids that are in here have been treated with some food coloring or something like that, like lamp oil and rubbing alcohol to give them some color. Water obviously was turned green. But someone created here a little density column of all these different things, and you can tell which liquids are the most dense, like honey and corn syrup, and which liquids are the least dense, like lamp oil and rubbing alcohol. And then what's kind of cool is that the solids over here on the right side will actually sink depending on how heavy or light they are. So ping pong balls are less dense than even lamp oil, so they float on the very top. A soda cap, like on a plastic cap, like on a 2-liter soda bottle, is basically going to end up kind of like right in that zone. It'll sink through the top 2 layers, and then it'll float on top of the vegetable oil. So it's kind of weird that they will sink down to their point. There's your cherry tomato, which has roughly the same density as like dish soap, and it floats on top of milk. Dye is actually like a dice, like a rolling piece of plastic. Popcorn kernels will sink all the way down through the maple syrup and float on top of that. If you're talking about a bolt, like a piece of metal, it'll sink all the way to the bottom. It's more dense even than honey. So maybe one of the lab activities I'll have you guys do is to try to create some sort of a density column at your house. I think that sounds like a fun way to torture my chem students. So one of the things about this, one of the main questions that we ask density is the basic question of sink or float. And how do you know if something will sink or float? Typically when we're doing sink or float, we're comparing it to the density of water. Although in that density column on the previous page, there's all different kinds of densities you could compare it to. But for the most part, when you're asking is something going to sink or is it going to float, we're usually talking about water. So the key point here is to know this, little factoid, which is that the density of water is by definition or by measurement, 1.0 grams for every milliliter, or 1.0 grams for a cubic centimeter of water. And a cubic centimeter of water is not very much. Again, think about a tiny box that's about a centimeter on the side, not a whole lot. And it weighs 1 gram. That's how much a gram is. So there's going to be in this particular problem, in this math demo that I've got going on here for you, there's going to be some problems like this. Like I've got a little example problem right here. Oops, sorry. Don't know what I'm doing now. Here with that. There's going to be some example density problems on here. And the way to use this particular video is to see if you can solve these. So what I would suggest that you do right now is pause it. You would hit pause, come back in a second, and I'll go work it out. But again, that's the easiest way for you to actually practice doing the skills. Get a little scratch piece of paper, kind of do it along on the side, and see if you know how to do it. So if you haven't done it yet, you should hit pause and see if you can figure out how to calculate the density of this particular material. Density of an object with a mass of 50 grams and a volume of 35.3 milliliters. Okay, hit pause. Did you hit pause? I don't think hit pause. All right, so we would use our equation. Density is mass divided by volume. And we've got a mass right here, 50 grams. And we've got a volume right here. Oops, don't know what that's doing. 35.3. So literally to calculate our density, it's actually super simple. We go density equals 50.0, and it'd be divided by 35.3. This is grams. This is milliliters. So my calculator says, what do we got here? 50 divided by 35.3. I get a crazy number like that, is what I get on there. So sig figs is still a thing. Density would be equal to 1.4164, something crazy like that. How many sig figs do we have in our problem? Okay, take a look. We got 3 sig figs in the milliliters. We got 3 sig figs in the mass. So that means we have to write this in 3 sig figs, which would be 1.4. And then I take a look at that next digit. The 1 is my third sig fig. Do I need to round up or round down? Again, the 6 means I would round it up, so it would be 1.42. And then my final units would be grams per milliliter. There we go. And that's how I would answer that. Is this object likely to be wood? Again, this is going to be one of those little problems. I'm going to have you guys look this up and figure out what this is. I'll have you guys look up some wood densities, and you can tell me that after this. So anyway, this particular material, 1.42 grams per milliliter. Would that sink or float? Well, the density of water is 1.0 grams per milliliter because it says so up there, and that's our constant. This stuff is 1.42 grams per milliliter, which means that this material is going to sink. It's just a little bit heavier than the density of water, so it's not going to float on top. It's going to sink down. Now, it's not a lot heavier, so it wouldn't necessarily sink like super fast. It's not like a rock or something like that, but it's something else that could kind of settle down in there. So anyway, 1.42 grams per milliliter. The answer to this one, sink or float, would be this one would sink because the density that we calculated is greater than the density of water. Okay, next one. How do we do this if we've got an awkwardly shaped object? Like, not every object has a beautiful little rectangular shape. This one kind of shows you over here on the right, we've got our irregular solid. This is a really common thing. This is a lab that we'd be doing if we were back at school. We would take a graduated cylinder like this one, and we would have some water in the graduated cylinder, and we'd take a look at, try to read what the level in that graduated cylinder was. And then we would do this thing called the water displacement method. I would literally drop my rock or my object in there and then take a look at what happened. And so this value right here, the difference between here and there, that original value, that's basically the volume of the object. It's called water displacement. However much the water level moved up, that's the volume of the water that we had. So if we're trying to do something along these lines, density is mass divided by volume. One more time. We know how much it weighs because it weighs 88.95 grams. Sorry, I kind of got that in the wrong spot. My pen's not working right. 88.95 grams. And then we have to figure out what the volume is. So to look at our graduated cylinders, we have to look really carefully at reading our graduated cylinder and try to figure out what that is. So you can see up at the top, I kind of have it described. Assume that each line is 1 cubic centimeter or 1 milliliter, same thing. And the bottom line is 5. So this line down here is 5. So this line up here would be 10. This would be 15. And this would be 20. And it looks like it's pretty much right on there. 20 ml. Or, wow, my pen's really weird. 20 milliliters to start. And then if I take a look at my new volume, kind of worked out nicely. There's 5, there's 10, there's 15, there's 20, there's 25, there's 30. So this is 30 mils now. In order to figure out what my volume is, I don't put the 20 in there. It's not how much the volume of the rock is. And I don't put 30 in there. I got to put the change in volume. How much did the water line go up? Because it's the change. That's what's really important to us. It's not like it has a volume of 20. That's what we started with. It's not a volume of 30. That's what we've got, rock plus water. I just want to know what the rock is. So I subtract the two, 30 minus 20. In this case, it's a pretty easy math, 10.0 ml or cubic centimeters. Either one is the same measurement. So in order to do this math in there, I would know that it would be 8.895 grams per cubic centimeter would be the answer to this. So now your job is going to be to do this part and go figure out if this is going to be aluminum, iron, or nickel. So how do you do that? Well, Google it. That's what you're going to end up doing. You're going to go look up a table of densities someplace. Again, make sure that it is in the correct set of units. So you want to be looking for units that are metric units, grams per cubic centimeter. You'll see a variety of different tables. Sometimes it's in grams per liter. Sometimes it's in grams per or kilograms per something or other. So make sure you're looking for one that's in grams per cubic centimeter. And then I want you to tell me if you think that this particular metal or this particular material with a density of 8.895 is more likely to be aluminum, iron, or nickel. So again, I'll have you guys go look that up. Almost done. Some of our harder problems are like this style, where we're actually going to be taking advantage of some basic geometry. With basic geometry, I know you can figure out what volume is. Volume is length times width times height when you're talking about a rectangular solid. So if you have a cube like this and you know the length, width, and height, this type of a problem is called a missing sides problem. So we know, for example, that this particular material is copper. And I'm giving you the density of copper here. I looked it up, and I know that the density of copper here is about 8.92 grams per cubic centimeter. I'm also giving you this bit of information, which is the mass of that piece of copper, that it's 172.3 grams. So question number 1, what's the volume of the block? And then question number 2, what's the missing side? So take a second and pause the video and make sure that you can answer question number 1 here, do the quick calculation. And then if you want to, go ahead and try to do this one. Again, it's just a basic little piece of algebra at this point, but I'll come back and do both these in a second. So hit pause, figure out what the volume of the block is, be careful with your algebra, and then we'll come back and figure out the missing sign. So hit pause. Did you hit pause? Okay, here we go. So density equals mass divided by volume. We know the density, 8.92, because that's given to us in the problem. We know the mass of it, which is 172.3 grams. And then we're trying to find the volume to it. A lot of students have trouble with the algebra on this, so please kind of watch closely. If I want to get this volume out from underneath, I kind of have to multiply both sides by volume to get that out from under there. So the algebra ends up looking like this: 8.92 times V equals 172.3. Again, for some reason, students like to do this one upside down. Again, what I did was I multiplied this side times V so I could get these two to cancel out, which means I have to multiply this side by V. That's kind of what I did there. So again, 8.92 times V is 172.3. And then in order to solve for V, I have to now divide both sides by 8.92. So my calculator says 172.3 divided by 8.92. And I get a calculator value of, what does that say, 19.3 or so. So if I solve for my V, again, what I did here, divided by both sides, 172.3 divided by 8.92, and I get V equals 3 sig figs in our problem. Yep, looks like 3 sig figs, 19.3. And this would be cubic centimeters. There we go. So there's our volume. So this last one down here, again, is our missing side kind of issue. I'm telling you now, we know something about this. We know its volume, it's 19.3. And we know two things about it. We know the length of the block, because it's 3.5. We know the height of the block, it's 1.8. So we know that 3.5 times 1.8 times width has got to be equal to volume, 19.3. And again, all you're trying to do now is just solve for what your missing side is. So 19.3 divided by 1.8 divided by 3.5. 19.3 divided by 1.8 equals, and then divided by 3.5 equals. And there's what my calculator says, 3.06 or so. And I know that my missing side have to be 3.06 with 3 sig figs. And this is in centimeters because it's a length. So there you go. Missing side kinds of problems. Again, we only do those typically when you have a cube, a rectangular solid. If you do it with a cube, by the way, where it's truly the same all the way around, length times width times height, then you know that it's literally this times this times this. It's going to be the same dimension times itself. So it's to the third power. Kind of works out pretty well. Or not to the third power. Length times width times height. Yeah, to the third power. So you can kind of do a square root if you really want to. So there you go. This is we've got two final kind of challenge problems that are on here. And again, these are things I'm going to ask you to kind of work on and do here in a second. I'm going to post up the answer to this one tomorrow. So I need to give you a little bit of time to work on this and try to figure out what you're working on. So number one, I'm going to ask you to do this one. I want to know how much these blocks of gold weigh. So over here, you've got a nice little lovely pile of gold. Can you imagine having that for Federal Reserve? Thank you so much. Each measurement is right down here. These are in inches. So you can tell this is going to be the Wunderfractions. Yeah, I knew you wanted a Wunderfraction for your time off at home. So you're going to need to do a little bit of conversion here. So I would say the first thing that you do is take those numbers. Sorry, my pen is being super weird right now. I would take those numbers over here and convert to centimeters first. That's going to be the easiest thing. Second thing I know is over here, my little top, I've got the density of gold is given to you, 19.32. And the density of gold here is given in the units of grams per cubic centimeter. So this little actual piece of gold right here is 1 centimeter by 1 centimeter by 1 centimeter, and it weighs 19.32 grams. So that's kind of what the density of gold is. So your job is to figure out how much each of these bricks weigh. And I would like to know it in, I'm trying to decide if I want it in kilo. I think I want it in, two different answers. I think I'm going to want to know in kilograms. So do that number one. That'll be the first one because you're going to start with grams. And then the second one I want to do is convert it to pounds. So I want two different answers from you. How many kilograms does each gold block weigh? And then how many pounds does each gold block weigh? So again, you're going to have to do a little bit of dimensional analysis, convert each of these into centimeters. Do a little dimensional analysis. Here's your conversion right here. Then you can use your density equation, and then you can convert your answers into kilograms and pounds. Like I said, I'll post a follow-up with the answers to this tomorrow. See if you can get this one done. And then last but not least, here's our final question for today. This is going to be an assignment that is going to be worth kind of more points. So we call this a performance assessment. Basically, have you learned anything? So as a process of doing this, your job is going to be to basically set up a little argument for me. I want to know if Saturn floats or if Saturn sinks. Again, know that the density of water is given to you on there, 1.0 gram per milliliter, 1.0 gram per cubic centimeter. You're going to use Google to go find some things. Now, I know you can Google the answer to this and you can actually figure it out, and that's totally fine. You're going to have to go look up some stuff anyway, because if you need to do density, mass divided by volume, you need to know the mass of Saturn and you need to know the volume of Saturn. You're going to have to go find those. So when you're doing your work, the stuff that you're going to have to give me eventually is you're going to do this on like a piece of notebook paper, and I'll have you either submit it as like a Google slide, or maybe we'll come together as a group and we'll share it that way, something like that. Don't know which one we're going to do, but I need you to make a claim. So when you make your claim, your thing is just going to be, yep, it sinks, or nope, it floats. A claim is pretty simple, and that you're going to do that kind of after you've done your calculations. You need to have that part done. Second thing is, you're going to need to show me all of your evidence. This means that you have to show me all of your calculations. So if you go look up the mass of the planet, if you go look up the volume of the planet, that's great. But you're also going to have to show me those conversions. You're going to need to show me dimensional analysis, Wunderfractions, yeah, because I'm pretty sure that they're not going to give you the mass of Saturn in grams. I'm pretty sure they're going to give it to you in kilograms or something else. Same thing for the volume of it. I don't know if they're going to, if they're going to give you cubic centimeters or something else, but you're going to have to figure out how to do that particular conversion as well. I would suggest finding it in liters might work, but you're going to provide your evidence. So show me what you think the density of Saturn is. And again, if you want to go look up the density of Saturn and check your work, you go for it, man. That's fine. But I need to see how you got there. That's providing your evidence. And then the last thing is that you're going to do, you're going to describe your reasoning. So remember, this is claim, evidence, reasoning. What's reasoning in this case? Reasoning is the science part. This is basically where you're going to talk to me about density and how can we use density? Why is it characteristic? Why is it something that we can use to apply to something like this? Anyway, so that's what I want you to know. You in density part, maybe you talk about sinking and floating. You talking about, how density is calculated, something along those lines. So it's going to be a little three-part answer. The claim is the quickest one. The evidence is going to look mostly like math, although it should be kind of labeled math so we can read it and follow it. And then your reasoning is going to be a couple of sentences that talks about what density is, how we calculate it, and how we can determine if something floats using density. So there you go. That is your 5.5 lesson kind of video. Has everything to do with density. You should be able to go and finish up a good part of your density, that standards page that you have, and you can do that a couple of different ways. Again, if you need to go look up some density problems to go find something to work with, that's fine. You can make up your own. That's also fine. But again, I'll post up some answers to the couple of questions, the gold question, and some of the other ones that are in here later. And then you need to figure out about whether or not Saturn will sink or float. Okay. All right. Hang in there, you guys, and enjoy doing some science work with your brain for once. I'm sure you guys have all turned into vegetables. I will talk to you guys soon. Have fun.